Welcome dear students, we are on the CEC Gurukul lecture and we are in the series of electronic circuit. In this electronic circuit series, we are discussing the printed electronics. Printed electronics nowadays is a very new technology, and it is having a grown interest from the scientific community, and it considered to be in an early stage of the development. And most of the printing technology we have discussed, in which we discussed the contact and non-contact printing technology. So we are discussing some non-contact printing technology, in which today we will discuss some of the printing technology, in which first we discuss the inkjet printing. In the inkjet printing technology, a content stored in a digital format is transferred by the direct deposition from the small openings in the print heads without the use of the mask, without any contact between the print head and the substrates. It means when we just give the drawing to the system, and it will print on the substrate, and it comes in the droplet fluid or the powder, protein or the mineral, conductive polymers and nanoparticles we will use for this purpose, for the inkjet printing. And a wide range of material we can use in the inkjet printing according to its application, like bioactive fluids which cannot tolerate exposure to the photolithography and etching chemical present in the conventional techniques. Under the print head ejection, the gravity force, air resistance, so the ink is projected into a specified position of the substrate, creating the printing patterns for an electronic device or for electronic gadgets. In the case of the fluid, it dries through the evaporation of the solvent. It means we prepare the ink by dissolving the powder into the solvent, and then when we print it on the substrate, the solvent will evaporate, leaving the particular material by the chemical changes, for example cross-linking of the polymers or crystallization. Eventually, a post-processing treatment is required as a thermal annealing or sintering process. Means when compared to the other deposition methods, inkjet printing technology is adaptable for patterning on a high variety of the substrate. Substrates, we can take the glass, plastic, paper, textile or any flexible substrate we can use for the printing. If we talk about the substrate, variety of substrates in which we can take the rigid, we can take the flexible substrate, we can take the smooth surface, we can take the rough surface, in which we can use some type of substrates are glass, plastic, paper, textile, flexible substrate we can use with the low consumption of the raw materials and low level of the waste production harmful to the environment. So, inkjet printing technology is intended for a wide range of application for drawing or for the preparation of the nano-sized transistor, structural polymers and ceramic, biomimetic and biomedical materials printed for the growth of the living tissues as well as the building of the 3D electrical circuit. We can just draw the MEMS and sensors in a mask level. In a mask level, we can prepare by using the inkjet printing technology. No special processing condition we require here. Inkjet printing stands out for being the one-step process with a simple operating principle, reduced number of the manufacturing steps and possibility of using low cost and raw material. Means we require the ink. Moreover, we require the pattern. By giving the pattern to the system, digitally we can print it on the substrate. And moreover, the thickness around the nanometer range is easily achieved by increasing the electric field value along with the distance between the print head and the substrates. a very thin film, a very thin device we can print by using this inkjet printing. The use of ink have a particular set of the physical specification in the particular of its viscosity is a superficial tension and amount of the humectants. Means whenever we use the ink, then we choose the ink according to the application for the purpose. Like we just we see the sum of the physical specification in which the viscosity, concentration, surface tension are the main point just for checking the or just selecting the ink. Sometimes modification on the ink viscosity, concentration and solvent system are necessary for proper droplet injection without blocking the nozzle, as the ink should flow smoothly through the nozzle, so it should not be block the nozzle. So, the concentration and viscosity and the solvent we will choose accordingly. Although the low process velocity and the possible clogging of the nozzles presenting a challenge the industrial production, and moreover the cleaning of the nozzle is required time to time as we use it. So, IPT becomes ideal for laboratory research, providing the innovative fabrication, high quality and low cost production, because we can print a number of times of the same pattern on the substrate. So, mainly we use the two mechanisms for actuation of the inkjet nozzle head have been developed, that is we use the thermal or the piezoelectric. That is the thermal and piezoelectric droplets in very small diameters are ejected at each corresponding pulse and generated by either thermal or by the piezoelectric actuators used in the inkjet nozzle head. Means as we are preparing a nano devices or we are preparing a very thin devices, so the droplet which is coming out through the nozzle in a very small diameter, it should be smooth so that it would not damage the structure. Means droplet ejection through piezoelectric, thermal inkjet material printer. Typically the nozzle diameter used for the inkjet heads range from the 10 to 150 micrometer, and the reservoir ink with a volume of the capacity of 3 ml only. You see on the screen that this is a very simple process, that is the droplet actuation mechanism of inkjet material printer. You see here we are having a ink reservoir, after that we are having the silver ink, then we have a nozzle, and then nozzle having a ink droplet, and you see right hand side we are having a piezoelectric and thermal element that is used for the just for the flow of the ink through the nozzle. And then you see the substrate, and the pattern that we will already have is just printed on the substrate which is in motion. Now see, or either the substrate is in motion or the nozzle is in motion. So, droplet actuation mechanism of the inkjet printer is here. Now, the actuating element is either the thermal or the piezoelectric. In case of the thermal actuators, a filament is embedded in the nozzle head, and upon the voltage application, a bubble is generated in the nozzle that pushes ink to the nozzle tip and generates the droplet. Otherwise, in case of the piezoelectric element, piezoelectric crystal is placed inside the nozzle, and upon the voltage application, piezoelectric crystal vibrates, and as a result, pressure exerts on the ink inside the nozzle and droplets generates. So, by means of the thermal or by means of the piezoelectric, we can just make the droplet out from the nozzle. So, the droplet actuation mechanism of the inkjet material printer, ink must be filled in the reservoir. Driving the signal is applied to the actuating element that generates the droplets according to the designed geometry which is given to the system. System means already we can define the pattern which we want on the substrate. So, inkjet printer are further divided into the two types. Number one is the continuous inkjet, second drop on demand system. Continuous inkjet, continuously the droplets are coming out, drop on demand, as per requirement the drop of the ink will come out. So, in the continuous inkjet printer, the ink is stored in a reservoir supplied to the nozzle. A charging electrode is used to pull the ink out of the nozzle and form a droplet. And after droplet formation, deflection plates are used to direct the droplets on the targeted area on the substrate. So, this kind of printing system is used in the industry for printing on the package such as expiry dates commonly seen on the boxes and drinks of the liquid bottles. Apart from this, the droplets are not controlled by the input signal. The CIG system continuously produces the droplet with a certain frequency, hence the unused droplets are directed to the recycling system where the ink is stored and it is reused. That is the same system. On the other hand, if we talk about the drop on demand, then the system is controlled by the digital input signal that comes from the design of the pattern. In the DOD system, each droplet is generated on the demand. Hence, there is no need of the deflection and the charge of the electrodes. So, the substrate is kept perpendicular to the nozzle and droplet sit on the substrates one by one. And the substrate is moved separately through a control system synchronized with the droplet generation in order to make a pattern or the thin film on the substrate. So, the number of nozzles in commercial inkjet print head ranges, which is from the 1 to 128 with the ink droplet as small as the 1.0 PL. You see on the screen that here this is the drop on demand inkjet printer, like a continuous inkjet system, and right hand side we are having a drop on demand inkjet printer. So, here we are having a nozzle and just the drops are coming out and deflection is decided by the thermal or the piezo. But here in the drop on demand inkjet printer you can see that the nozzle the nozzle and the droplet which can be done without the intervene. Okay. Now, the inkjet printing technology produces the droplet of the ink contained in the fluid channel with a diameter ranging from the 10 to 150 micrometer, which approximately corresponding to the diameter of the nozzle. So, the volume of the droplet is in the picoliter range. So, a very small droplet of the ink will come out for the printing. This technology is considered suitable for the printed electronics due to the following reason. Number one, it is non-contact process that selectively deposits a wide range of the material onto a wide range of the substrates in a drop by drop manner. The shop floor space requirement, the initial investment as well as the commissioning time to get an inkjet printing setup running are low than most of the other printing technology. It is suitable for the wide range of the production scales, as it is very easy. One prototype we can having, then the large number of the device we can just print on the substrate. ink consumption and the material wastage are very minimal in this case. It is flexible with regard to the positioning within a process chain. Moreover, any substrate we can take for the printing purposes. It can produce the pattern thin film, a key requirement for the organic electronics. It shall be mentioned, however, that the manufacturing of the highly complex integrated circuit has exclusively been performed by the specialized techniques deviating from standard inkjet to meet the requirement of the high spatial resolution for the ultra short transistor channel length. Finally, if we talk about, it is possible to add the functionality using inkjet printing on a substrate that already has the electronic structure and devices fabricated using any other technology. Means by using this inkjet technology, we can enhance or we can change the structure as already defined or printed by the other, fabricated by the other techniques. So it is a non-contact, maskless and masterless nature, along with the freedom to position the print head directly on the top of any 3D coordinate of the substance, enable this aspect. So again we can see the key point of this continuous inkjet: ink column under the pressure. We can ink column under the pressure, means we are having a thermal on and we are having the piezoelectric. A stream of the ink droplet continuously ejected by the nozzle, change droplet deflected and positioned using the electric field, remaining droplet collected by a gutter and it is recycled. Next is a drop on demand. Droplets injected on the demand, e.g. when an image pixels is on. Simpler system than continuous inkjet. Multiple actuation mechanism listed below. Here we can see thermal, piezo and electrostatic. In the thermal, the flash heating of the ink by heating element. In case of the piezo, voltage pulse applied to the piezoelectric transducers, and in the electrostatic form we can have the electric field exist between the inkjet setup and the substrate. So these are the three points which are used in the drop on demand inkjet printing. So now we have the classification of the most common inkjet printing technology which is used for the further purposes that we are having that for the continuous printing potential, it is sometimes a wasteful process as a result of the continuous generation of the droplet irrespective of the presence or absence of the information at the each pixel of the image of the text to be reproduced. However, continuous inkjet printing has its advantages when it comes to the work on the substrates with a non-planar geometry. If we talk about the DOT inkjet technology, and it is connected with the thermal and electrostatic inkjet lag, and far behind the piezo inkjet, mainly is due to the following reason. Thermal inkjet can lead to degradation of the functional material present in the ink due to the cyclic thermal loading. Piezo inkjet on the other hand is an isothermal process. Thermal inkjet has successfully proven suitable for the manufacturing of the light emitting diodes based upon the inorganic quantum dots. The range of the ink solvent that could be used in the piezo inkjet is much broader than that of the thermal and electrostatic inkjet. So, investment and running cost needed for the electrostatic inkjet is much higher as than of the piezo inkjet. So, moreover, this technique is still under the development and it is not as mature as either a piezo or the thermal inkjet. So, if we talk about the piezo inkjet system, then it is consists of a piezoelectric transducers, and that is a PZT, that is actuated by a voltage pulse, and this is called the inverse piezoelectric effect. And in the commercial printing system, the frequency of the voltage pulse usually ranging from the 1 kilohertz to the 20 kilohertz. And moreover, we can see the piezoelectric transducer in the previous lectures. There we defined that how the piezoelectric effect used and how we can just prepare the transducers. That transducers we can just prepare by using the inkjet printing, and that is a pressure. As a result of the piezo actuation, pressure waves are generated and these are propagated within the ink channel, and the droplet are generated and acoustic frequencies. So, commonly use the bipolar waveforms along with the brief description of the significance of each segment of the waveform. It is just an example. Many different type of the waveforms are usually be applied to an inkjet print head to create the droplets, and the profile and the magnitude of the applied waveforms depend on the nozzle dimensions, the rheology of the ink used, the droplet size, the velocity we desired. So, a sequence of pictures depicting the formation of the droplet from a piezoelectric nozzle. You see that this is a exemplary bipolar waveform for the piezo actuation. Like you see, here we are having a voltage, it is applied, then initial fluid expansion, then relay for the wave propagation, now the fluid compression, finally just we have delay the wave propagation, then the wave cancelling fluid expansion, and in this manner a particular size of the nozzle can just flow the drop or can just eject the drop at a particular size. You see, these are the nozzle, and on the basis of the force applied, then it thus giving the droplet. You see, it is having a 0 microsecond, 40 microsecond, 60 microsecond and 100 microsecond. The droplet will leave the nozzle and it will just draw the picture on the substrate. So, droplet formation sequence from the nozzle of a piezo inkjet print head. Now, this is the process how the droplet will come out from the nozzle. What is the requirement of the inkjet printing? While we are having a different type of inkjet printing technology mentioned earlier and more or less have the similar requirement with respect to the material. Moreover, we use the ink material we require. Moreover, the pre-processing of the substrate and the post-processing of the printed structure. This will especially for the requirement of the piezo inkjet. Means first we require the ink, number 2 ink and its specific parameter, ink with the specific parameters. Number 2 we require the substrate. After that we require the printed structure and its functioning and its check. So, what is the substrate we are using? As mentioned earlier, the inkjet printed itself does not depend on the substrate. It is possible to use any type of the substrate like rigid, flexible, reinforced and the non-reinforced. However, the interaction of the printed ink and the substrates play a decisive role in determining the accuracy and robustness of the printed structure, and the ink properties and the substrates properties have to be well matched. As a result, the substrate surface is usually processed prior to the printing in order to improve the wetting adhesion like that. Plasma treatment and the other treatments are widely used for this purpose. For high definition structure substrates patterning, for means we are having a partitioning the substrate surface into the hydraulic and the hydrophobic areas. So we can use. Another is the ink. The ink used for the printing electronics are either the dispersed or the dissolved dye-like in one or more solvent. The role of the solvent is to provide a vehicle by means which the functional material could be carried out through the printable on the ejected via the nozzle. In the context of the printed electronics, a functional material fulfills the electronic electrical functionality like conductivity, like superconductivity, like semiconductivity, resistivity and the dielectricity. Many type of the inks that fulfill this functionality are commercially available. So this type of ink we can take. And now the further we will discuss the things in the next lecture. Thank you very much.